Okay, today is the last lecture about iteration, and you may feel, oh boy, why there's another lecture about iteration? Well, the reason is the iteration is definitely one of the most important topic in this lecture, and if you, well, also it's the hardest topic, and if you manage to go over this biggest challenge in this course in the rest of this semester, you may still feel like we are learning new things every week. Well, but I guarantee you, this one, the iteration part is definitely the hardest because number one, it's hard to code, and number two, it's also hard to debug. And if you are still surviving by far, and congratulations, you're almost getting there. Okay, well, let's do a very quick review on what we have covered in the last lecture. We talk about the difference between definite and indefinite loop, and for the definite loop, that's an iteration that we know how many runs we are going to run, and for the indefinite loop, we don't know that information. And then we talk about the break statement. And remember, for a break statement, it will do a immediate shutdown, a immediate stop of the whole iteration. So, well, let me give you an example. If I have a definite loop, I know it can run for 10 rounds, okay? And then in round 5, if the break statement is triggered, what does that mean? This means for the round 6 to round 10, they are going to be totally ignored and be shut down the whole iteration. And that is the power of the break. And why do we need to use a break? We use a break if we want to add one additional conditional exit to the iteration. When this case is going to be triggered, and then even though we don't quite finish the whole 10 iterations, when this break is triggered here at round 5, and then the whole iteration is going to be shut down. Okay, and well, and this is the analogy of the break. So originally we are in this iteration, we are in this circle, but when a break is triggered, and then we just exit the whole loop. Okay, and today we are going to see a few more examples and exercises, and we are going to learn a new statement, which is continue. And at the very last, and we will see a few very tricky examples and very hard code for us to debug. And I'm gonna talk a little bit on how we can debug a iteration. Okay, well, this is the question from the textbook. Well, if we want to create this program asks the user to choose a positive integer and then print the numbers from 1 up to that integer. Say if I type 100, and then this program will print all the numbers from 1 to 3 all the way up to 100. Okay, so can we write a program with a while loop? Can we write this program with a for loop? Or can we do this program with both? So think about that. Well, let me ask you this question. Is this program a definite loop or a indefinite loop? The answer is this is a definite loop. The reason is the user will give me a number, and that will be the number of the rounds we are going to run, right? So when we start this iteration, we have already received how many numbers we are going to run. So this is a definite loop. So, okay, step one, this is a definite loop. And step two, if we want to do a definite loop, can we do with a for? Can we do with a while? Or can we do with both? And the answer is C, both. Okay, and this is the iteration. So for example, if we want to do that with a for loop, and then we first want to get the user input and give me the max number, and then the user will type me something, and I want to cast it into an integer, and then remember from 1 to that number included. So we are going to stop at the max num plus 1, and then we're going to do a for loop, and we are going to print each of the value from the 1 to the maximum plus 1 with the maximum plus 1 excluded. Okay, and how about we do that with a while? And again, well, for the val, we have to start one additional variable by ourselves. And I'm using I. I'm using I as the number that I want to visit. And then for each round, I visit one number, and then I increase the I value by 1. Okay, so I start I from 1, and then as long as I is smaller or equal to the maximum, and I'm printing the I value, and then I'm going to do a I plus 1. Well, if you want to compare the setup of those two possible versions, and you may find that for the while, we do have those two extra lines, and because we have those two extra lines, and coding the while can be a little bit harder. And well, if you're not that familiar with while, and you may have a little bit issue too. Okay. Well, here is another interesting example. Well, well, the process is like this. Well, if you receive a number, and then the rule is you find this n number if this n number is even, and then we are going to do a n equals n divided by 2. So we are cutting the n value by a half. And otherwise, if n is an odd value, and then we are updating the n value to 3 multiplied by n and then plus 1. And then we are going to keep on doing this until we reach 1. Okay, and there is, well, and there it is guaranteed if you follow this process that eventually you will get down to 1. So let's do 13 for example. So we start from 13. 13 is an odd number, so we are going to go to this step. So 13 multiplied by 3 and then plus 1, we will have 40, and then the new value will be 40, right? And then 40 is a even number. We want to do cut the value by half, so 40 down to 20. 20 is again an even number, so we cut the value again, we down to 10. And then when we down to 10, and then 10 down to 5, cut value again. Well, and when we are at 5, it is an odd number, so n equals n multiplied by 3 and plus 1, and then we get up to 16. And then we go down by half, go down by half, go down by half, and then eventually we have the 1. Okay, so well, I'm not going to prove that to you theoretically, but it's guaranteed as long as you have a positive integer. And then if you follow this process, and eventually you are going to go down to the value of 1. Okay, and then the question is, how do we do that? Well, or how about we ask this question: is that a definite loop or a indefinite loop? Well, of course, you see my code, and I did this with a indefinite loop. I'm doing a while, and as long as n is not 1 yet, I'm printing the n value, and then if it is even, I cut the value by 1/2. If it is odd, and then I do n multiplied by 3 and plus 1 and assign it back to n. And eventually, I'm trusting the mathematical proof behind the scene that it can be done, and eventually I'm gonna go down to 1. Okay, and well, it seems that a indefinite loop is the way to go, because from 13, for example, we definitely have no idea how many rounds we are going to go until we can go down to 1. Okay, well, but when I teach this part of the lecture several years ago, there was a student argue with me that if there is already a theoretical mathematical proof that which can prove that given any positive integer, and then we follow this process, we will go down to 1. And there might be another proof which can help us calculate how many rounds it's gonna take before we go down to 1. If there is already this kind of proof available, and then there might be a definite loop solution to this problem. So this is a very interesting argument, right? Well, so if we believe this kind of mathematical proof exists, which can help us figure out how many rounds it takes, and then probably this problem can also be solved with a definite loop. Well, I don't have this proof in my head, but probably there is such a proof there. Okay, so I'm gonna stop my lecture from here, and then the next part I'm gonna start to talk about the continue statement.